starting section 3.8, today and tomorrow, it's all about graphing tangent. We spent weeks graphing sine and cosine, right? We started out on day 1 with each of those functions by making a XY chart, and then we picked 5 good points, and then we never had to use those again, and then we just manipulated those points with the period and the midline and the phase shift and all that stuff. So you might see that tangent is very similar to sine and cosine, but almost a little bit easier, and I'll show you what I mean in a second. But just to know what tangent means, tan is sine over cosine, right? That's something we've talked about. Tan is also, you could also call it y over x, because sine is y, cosine is x. So you might think of it like that. Also, tan is the slope, okay? Because remember what slope is. Slope is y over x. That's what slope is, change in y over change in x. So tan is actually the slope of the hypotenuse of all your right triangles, or you can think of it as the terminal ray of all the angles of the unit circle. So if you found the slope of this line or this line, it's actually the tan value. Or you know the tan value of those angles, you know the slope of those lines. So tan's kind of special. Tan has a curve, just like sine and cosine had a curve, sometimes called a wave. And your teacher also calls it a squiggle. So when you hear me use that, when you see me graph tan, you'll understand why I call it a squiggle. That's not a real math word. That's just a Tracy Morse word, so just so you know. But when you hear me say squiggle, that'll make sense when we do it. All right? So what we're going to do, what I want you guys to do for me, please, is take a second and quiz yourself. No one has to know what you got right or what you got wrong. But I want you guys to see if you can remember by memory what the tan values are of these. And I'm going to do the same thing, and I'm going to freeze it, and then we'll uncover it. But take a second, see if you can remember, because trig isn't going away. So any opportunity we get to kind of just not copy down answers is an opportunity to see if it's still in our brain. So go ahead and see, fill in what you can. Get it wrong, it's no big deal, we'll fix it. But just see if you can quiz yourself right now on these tan values. I'm doing the same thing. Check your answers. Remember, all of your denominators of 6, denominators of 3, and denominators of 4, those are the tan tricks I taught you guys. Those are all quadrant 1. Tan is positive in quadrant 1. In quadrant 2, same values, right? Denominator 3, 4, and 6, just tan is negative in quadrant 2. All students, S is positive. And then there's 3 quadrantals on there. Notice that your teacher, who is good at trig, let's say great at trig, I still think of the ordered pairs. You can see I wrote them up there. And remember, 0 on top is 0. 0 in the denominator is undefined. I'm just doing y over x, just like we talked about up here. Sine over cosine or y over x, okay? So these are some of, from 0 to pi, half of the unit circle, a bunch of tan values, okay? And just like when we learned how to do sine and cosine, we don't graph this whole thing. We actually just pick certain points. So x is our theta, don't forget, and then this would be y, which is our tan values. Now, some of the ones that we use for our parent function are a little different from what you see up here. So I'll explain why. Just go ahead and write this first. That's negative pi over 4. Sorry, that should be a 2. Negative pi over 2. Sorry, then negative pi over 4. Then 0, pi over 4, and pi over 2. Okay, we're going to jump back in here in a second. Please be polite to Ms. Shaker. One of my big classes. Good to go? Yep, absolutely. All right. Hi, guys.
see some familiar faces right out there, but also wanted to reach out to Stuff Work. This is a really good opportunity for you. It's called Ace Business. This is Cambridge International Affiliated, so it's prestigious. The other thing about it is it is at the same level of an AP course and IB. You get college credit. So at the end of the year, you're writing a little bit of a paper, actually two shorter ones that are basically what have you learned about it and what about businesses across the world. So here's the trick. In it, you can find out about and you can analyze what are they doing out there that's right on businesses, or do you want to be your own entrepreneur, or if it is businesses, what's different about a business that's in India or the UK or Pakistan? Or what about in these classrooms in Countryside High School? What works for us? Will it work for people across the world? And that context and looking at different situations and how communication can have that. Right? That's a good class to know about. So they have it where you're at a high level as far as when you're analyzing. And that's what you learn to do. So you can do that. Every slide, you have to look at those top dots. If you look at top dots, you want to be a CEO in a company, you want to be a high management person, or you just want to start your own company, or know how to really effectively run a new department, right? Or bring value. A lot of times it's called an input to that. You're looking for a company instead of starting up, right? So this is what it's all about, is learning to think about things. We also do a lot of group projects that are like kind of fun things. They're short, they're long. And you say a short will be or a short movie, or a trailer. What we do is we will analyze something. So in this one, we kind of talk about food. So we didn't talk about, hey, what do you like for breakfast, right? Do you like donuts with cereal? Right? Think about the difference of your preferences and stuff, right? So in this one, this is one example where they had to make an ad. They had to come up with a different spin to beat the competition in a restaurant or some type of new food thing. What were they doing? Were they catering to people's needs or wants, right? Or special dietary stuff? Or the burger place and pizza. Whatever they did, they had a class to pop it together in, and then they presented it, and then students voted. So did they bring it in, right? What forced you to buy things and why? And how did they add more value in the competitive food, okay? So that's the kind of thing that we look at. We also look at the stuff. When you're looking at what companies you want to work for, you want to work for one that is going to be worried about the environment, sustainability, right? And also treating the workers fair, right? And so if you think about student voice is super important, right? You guys matter. But if you learn about empowerment now, and then how to use that in the workplace, that's going to help you out big time, right? So we talk about that. We talk about empowerment and student voice and impact when companies will let you interact and come up with the solutions and strategies, right? But it's empowerment. You want to be able to have that in your company, whether you're the person that's the leader and getting everybody involved, right? There are different management styles. So think about it. What kind of CEO do you want to be? Or what kind of CEO do you want to work for? What kind of company? And are they being held accountable for what they're doing out there? Right? This is an example. So these are where students present. You can see on this one, what was the big motivator? Money. But is it only money? And we look at that because, are you wanting a good work environment? Do you know how to challenge? And you want to love what you do. And you don't just look for a paycheck. You want to love what you're doing, whether it's your company or you're working for somebody else. So this looks you have the skills to do that, right? It also talks about when you have ownership, whether you're a student or a worker, when you have ownership, right, of that decision, it's more that buying and you're helping to take it to a better place, right? A better, more valuable place. Think about this. This is accountability for some different enterprises. Like they were talking about, this one is good, about motivating and caring for the workers. And they're like, well, Target has a ski discount, the Publix doesn't. Publix right now has a stop sign on it. So the community work in a Publix, they like to promote things. So you need to think about the environment. What do you want to do? You're going to do awesome things, not only just here at Countryside High School, but later on. So Mr. Bernstein suggested I come out and reach out to a commercial students. This is how they're math students and all the stuff we're learning, right? So he mentioned, come on in here, because Ace Business is not something that's known. We did our first prototype this year, okay? So please think about this for your schedules next semester and in the graphics. I'd love to have you guys winners, this was competition went well. We had a couple people that got MVP in the game several times, and then some that did it just once, right? But it was a big tournament. All right, thank you very much.
Of course. No class sports period.
Huh?
No class sports.
Yeah. That's good because the almanac.
Oh, good. Perfect. Thank you, Ms. Jaeger. Okay, so guys, I'll show you why on this next page, why we're picking these points. It'll make sense in a second. But let's just fill in these tan values real quick. So 0, we just found tan is 0. We found pi over 2 is undefined. We found pi over 4 is 1. Okay, so negative thetas, real quick guys, review of how to find negative angles. You go to wherever they're positive and cross the x-axis. That's it. So pi over 2 is at the top, so negative pi over 2 is down here. And remember, tan is undefined here and here. You have a denominator of 0. So we're undefined down there. And positive pi over 4, of course, is right here, cross the x-axis. Negative pi over 4 is coterminal with 7 pi over 4. So in quadrant 4, all students take calculus. That'd be a 1 because of the denominator 4 and negative. These are our 5 points that we use. Except when you have undefined, anybody want to take a guess? And I'll explain it better on the next page. Anybody want to take a guess as to what undefined would look like on a graph? Undefined going to look like a gap. What'd you say? Hole. There's a bigger, better type of hole. Place on the graph you can't touch. What's it called? Asymptote. So anywhere you have an undefined, it's an asymptote. So look, at negative pi over 2 and at pi over 2, just close one eye so I can see, pi over 2. And what that just did, guys, is it framed out our period. That's the first and the fifth point. I know it's not a point, it's an asymptote, but you get the idea. And then right dead center, you always have your x-intercept. And then at positive pi over 4, we're up at 1, and at negative pi over 4, you're down at negative 1. And it makes it look like a straight line, right? If I connected those, if there was no asymptotes there to stop me, it would just be a line with a positive slope. This is where the squiggle comes in. I just can't see, guys. I'm so sorry. This is where the squiggle comes in, and you just make a little squiggle. Arrows at the top, at the bottom. Asymptotes keep it in, so it can't keep going like a line. And that's it. Now what I want you guys to notice is the period. Remember, the period is how much of the x-axis we use to make our 5 quote-unquote points. From negative pi over 2 to pi over 2 is actually pi. So that's one of the only differences between tan and his friend sine and cosine. So you've been doing over and over again, 2 pi, 2 pi, 2 pi. Now you have to remember tan is just pi for this reason. Now why did I use some negative thetas instead of keeping it to 0 to pi? Well, technically you can use any 5 points. Any period of pi is fine. So from 0 to pi is 1 period. But when you graph that, it would have made like the top half of one squiggle, so it would have been that, right? And then it would have been this part of the graph here, wherever that would be, this maybe. So it just looks funny. How do you call that one graph? It is, technically, that's 1 period because it's from this to this is pi, but it just makes more sense to use from negative pi over 2 to pi over 2. So from here on out, you know your parent function has asymptotes from negative pi over 2 to pi over 2, and that's going to be really important when we get to another example here in a second, right? But before we get to that, let's just see what a flip looks like. That's your amplitude of 1, okay, with a flip. So the parent function still has, this is just the parent function with a flip. That's all this is. We're still at negative pi over 2 to pi over 2, a point right in the middle. And instead of our point, oh, so sorry. Stay on me. Instead of it graphing like a positive slope, an increasing graph, it goes the other way. So my point that's up is down, and my point that's down is up. Of course, the one in the middle can't flip over itself. So we would be here and here instead. So it looks like a line with a negative slope. It's a decreasing graph. And that's all a flip does. Okay, so I just wanted to show you what flipping a tangent looks like. So we got that out of the way. Now, I think I said it. Tan has an A, a B, a C, and a D, and they really all mean the same thing with tan. We just graph it a little bit differently, and this is where I think you're going to think it's easier. So let's go to our last page of the notes, example 4. And so today only, the only thing we're going to do is A or B. Tomorrow I'll introduce C and D, which really doesn't add much work to it. It's pretty much this graphing the same exact way. And so I want to remind you guys that what's in the parentheses, that is called the argument. Okay, what's in the parentheses? Whoever's hanging out with X, that's called the argument. Okay, and I'll come back to that in a second. So here we have 2 examples. Let's look at this first one. So if I were going to organize my information, I have an amplitude of 1, right, with a flip. And I can find my period the same way I found my period with sine and cosine. Except with sine and cosine, it was 2 pi divided by b. In tan, it's pi divided by b, okay? And b is 1/2, right? 1/2. So I would do pi over 1/2. Keep, change, flip, 2 pi. So having a b value that's not 1 is going to change how much of the x-axis we use. That happened with sine and cosine. But the way we graphed it with sine and cosine, like what I would have said to you guys here is, oh, your period is to 2 pi. You're going to graph from 0 to 2 pi and make your squiggle. But you don't do that with tan because we have asymptotes to deal with. So we make it really, really simple. Anytime you want to find, and I'm using more space up here, anytime you want to find your asymptotes, you're going to take your argument, so anything that's in the parentheses, and put it in between the parent function's asymptotes. And then solve for x. That will move your asymptotes, which moves your whole graph. So instead of actually maneuvering your points around the x-axis like we do for sine and cosine, you move your asymptotes. And so you'll see it's pretty simple. The only thing that I would say anyone struggles with is dealing with fractions without a calculator. We have to know how to multiply, divide, add, subtract with these denominators. We've been doing it already. Some of us are still not strong with it, so we need to make sure we know how to do it. So to find my asymptotes, which is how I graph, okay, I need my asymptotes first. I just take my, I'm just going to give myself some space here, negative pi over 2. Here's my argument, x over 2, and then pi over 2. And I'm going to solve for x. I want x by itself. Okay? So this is x divided by 2. So I will multiply by 2, right? So that will cancel. I multiply this guy by 2. The 2's will cancel. I'll be left with pi. There's an x there. And then you just do it one more time over here. Multiply this fraction by 2. Again, 2's cancel, left with negative pi. That's where my new asymptotes are. That took care of the change in period for us. So negative pi to pi. So that's framing out my period. That's going to tell me where my squiggle goes. The rest of it's really simple. I put my x-intercept right in the middle, dead center, and then you just have to decide, am I going to squiggle down left to right or up left to right? Since this is a flip, it's going to go like a negative slope. Think of it like that, okay? Like a negative slope of a line. And I'm going up to 1 right in the middle, down to 1, negative 1 right in the middle. It's all spaced evenly, just like sine and there it is. Now, this squiggle continues. You'll have more asymptote. It just keeps going forever and ever in both directions. So when we get to the homework, I'll show you how you figure out what the next one would be. You have to graph 2 periods. Okay? But let's do one more example. A would be 1, right? No flip. we have a b value of pi over 4. That should technically be in parentheses, I would say. B is pi over 4. So let's figure out our period. So it's pi divided by b. Keep change. B is, sorry, pi divided by pi over 4. Sorry, that's my b value, pi over 4. Keep change flip, my pi's will cancel, I'll be left with a period of 4. Now again, that is not, I'm not going to use that to make my 5 points. Sometimes the questions just ask what's the period, you need to know. And it's a good thing to check. Look here, 2 pi, here's 1 pi to backwards pi, that's a total of 2 pi. So we should be using 4 units after we make this graph. But we have to work with our asymptotes, that's the first thing we need for graphing. So remember, you take your negative pi over 2, your arguments, to pi over 2. So that's memorization, knowing that you're always, every single time you get a new TN problem, to find your asymptotes, you put your arguments in between negative pi over 2 and pi over 2, and then you have to solve for x. So guys, this is what I mean about the fractions. Pi over 4 times x, that's what we have going on here. Opposite of multiplication is division. So technically I'm going to divide everybody by pi over 4. But think a step ahead. Instead of writing divided by pi over 4, divided by pi over 4, divided by pi over 4, well now I'm going to have to do another step, which is keep, change, flip, right? Instead of that, what could I do? Instead of dividing by pi over 4, I could what? Multiply by what? Multiply by the reciprocal. Guys, look, if I had, because I would say the biggest question I had today was dealing with these fractions. So let me just show you something. What you don't want to have to do. And I'll show you the shortcut. You say, okay, that's multiplication. I'm going to divide you by pi over 4, divide you by pi over 4, divide you by pi over 4. Okay? So we know that we're going to get an x there. But how do I deal with this? Oh, I'm going to keep, change, flip, right? Keep negative pi over 2, change division to times, flip the bottom fraction. Pi's cancel, negative 4 over 2 is negative 2. Same thing over here. Keep the numerator, change division to times, flip the bottom fraction. And I get 4 over 2, which is 2. So I get negative 2 to 2. Well, instead of doing that, look guys, instead of doing that in 2 steps, at this step, what could I have done? What am I actually doing as my math when I got my answer? What did I actually do? No, I didn't multiply by 4. Multiplied by what? Somebody said it, I heard it. 4 over pi. Guys, that's what I did. I multiplied by the reciprocal, right? I flipped pi over 4 to 4 over pi. So instead of doing this in 2 steps, where I know when I divide by a fraction, I'm going to have to keep, change, flip, go ahead and just do the flip down. Multiply by the flip, also known as the reciprocal. Then you don't have to do 2 steps. And that will get me negative 2, x, and 2. From negative 2 to 2, those are my asymptotes, that's 4. Total of 4. Right in the middle is my x-intercept, and it's a positive tan. So I'm going to go up. It's an increasing function. It's rising left to right. Got to know how to deal with those fractions, because that's probably the hardest part of any of this, is just knowing how to deal with fractions. Okay? The graphing is easy. Squiggling is easy. Right? Let's go to the homework, and I'm going to start it with you on page 98. I'll do 1 and 2. Thank you. The instructions are to pull some characteristics out and graph 2 periods. So as for A, okay, A is 1/2. The period, well, B is 1. So I don't really need to do that whole asymptote thing. Whenever B is 1, x is by itself, your period is just whatever the parent function was, pi. And our first set of asymptotes, I say first set because we're graphing 2 periods, are exactly what the parent function are, negative pi over 2 and pi over 2. So remember, that's memorization, knowing that the parent function's asymptotes are from negative pi over 2 to pi over 2. We did not have a b value that was going to change it, so it's not changed. And there's no flip. I have my middle half. B is 1/2. I mean, A is 1/2. Whoops, did I do it the wrong way? I did. It goes this way. Right. It's a positive 1/2. So, rising, just like a slope with a positive slope, line with a positive slope. All right, but we have to graph 2 periods. You could go to the right or the left. It technically doesn't matter. This is important, how long the period is, okay? So I need to go out another pi. This is pi. I need to go out another pi. You might be able to, some of you can look at the x-axis, do a little mental math and tell, but here's the math of it. My last point, or asymptote, was at pi over 2. I have to add pi to that. That'll give me how far out pi is. Again, you won't have a calculator for this. We have to know how to deal with fractions without common denominators. That's 2 over 2, right? That's 1 pi, which is 3 pi over 2. So that's where my other asymptote is. Middle, just another squiggle. So the asymptotes are really the only work we have to do. The squiggle's really easy. Question on that one? Amplitude of 2 with a flip. Period. Yep, there's a b value. So my period is going to change. That would be pi divided by b. b is 2. Period is pi over 2. No simplifying there. Are my asymptotes going to move from the parent function? Yep, because we have a b value. So you put your argument in between, is 2x, negative pi over 2 to pi over 2. And I have to get x by itself. So just think of basic math, algebra, what you've done your whole life. How did I get x by itself? Well, this is 2 times x. I would divide by 2. But look ahead. When I do pi over 2, I do pi over 2 divided by 2, I'm going to have to keep, change, flip, right? This is 2 over 1, right? Instead of doing 2 steps, jump right into multiplying by the reciprocal, okay? So I'm going to multiply this guy by 1/2, this guy by 1/2, this guy by 1/2. And that gets me negative pi over 4 to pi over 4. If you need to show more work, go ahead, but I'm trying to save you from having to keep, change, flip, and then do the math. If you know you're going to have to flip it in the first step. So we have our first 2 asymptotes from negative pi over 4 to pi over 4. Remember, pi over 4 is in between 0 and pi over 2. Think of your unit circle. Where is pi over 4? It's in between 0 and pi over 2. So it's a little skinny one. So there's my middle. And then I have a flip, so it's going to go this way. I'm up at 2 right in the middle, down at 2 right in the middle. This skinny little squiggle. Now I need to find my next asymptote, right? I'm at pi over 4. What am I going to add to pi over 4 to get to my next asymptote? Not pi. Anybody else want to try? What am I going to add to pi over 4 to get to my next asymptote? Pi over 2, my period, right? Remember, I'm trying to find where my next asymptote is. from one asymptote to the next, I should have pi over 2 forever and ever. Pi over 2, pi over 2, pi over 2. So at pi over 4, if I add pi over 2, I would get 3 pi over 4. Mental math, a quarter plus a half is 3/4, or you could have found a common denominator. You figure out what you need to do. And then 3 pi over 4 is right in between pi over 2 and pi. Set that there. And I could have gone the other way. You can go to the right or the left of your first squiggle. It doesn't make a difference. All right. So I'll put the key up. Guys, don't just copy. You need to practice dealing with the fractions. Use my key to check, not to copy. You will regret that. There's some working in reverse, too. Remember at the top is it? Oh, you can get rid of everything but the most recent test results. But of course, the pin sheets, too. You want to get rid of those. Yep, sure.